Welcome to Pomodoro Joe for Tuesday, February 14th, 2023. Today we're doing LeetCode problem 67, add binary. It's an easy problem. Given two binary strings, A and B, return their sum as a binary string. That's the whole problem statement. So what is a binary string? Well, based on the examples, it looks like a binary string is just a string that represents a binary number. Okay. Seems pretty straightforward. So if you aren't familiar with binary numbers, then this one might pose a problem for you. I'll try to leave some links to resources in the description. You can check those out and learn a bit about binary numbers and binary arithmetic. All right, well with that, we will put 25 minutes on the Pomodoro timer and get started. And we will start with a result. And that will start as an empty string. Then we will return the result at the end. Okay, so how do we approach this problem? We have two strings that represent binary numbers, and it looks like, they don't tell us this, but it looks like the least significant bit is on the right-hand side, based on this example here. Yes, otherwise this wouldn't be a 0. So, because we are moving from right to left on this string, calculating our sum, I think I'll need to keep track of the index of where we are in our string, starting at the furthest right element in each string and moving towards 0. So I'll have an A index and a B index. So the A index will be the length of A minus 1, and the B index will be the length of B minus 1. Now we just have to go through every single index in A and B. So let's see. Wow. So we're going to say while our A index is greater than 0 or the B index is greater than 0. So as long as we still have some elements to process in one of our strings, we need to keep going. I know we're going to be moving from right to left, or the largest index down to 0, so I will decrement my index here. This will be at the end of our loop, but I'm going to do it now so I don't forget and end up in an endless loop. The next step, I need to pull out what characters exist at these indexes, or indices, in our strings. So our A value and our B value. That's just going to be our A at A index. So the A value is going to be A at A index, and the B value will be B at B index. Now, what happens if A is longer than B or B is longer than A? One of these indices is going to go into negative digits. So I need to check if we're going below 0, and if that's the case, we're just going to substitute a 0 in for that value. If we run out of characters in A before we run out of characters in B, I don't want to go into negative indices, which is something you can do in Python. It will just wrap around to the other side of A. Instead, I want to substitute a 0, so we'll be adding 0 to any element in B. And we have to do the same for B. Okay, now we get into the addition part. So how does binary addition work? Well, pretty straightforward. We have 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. And 1 plus 1 is equal to 0 plus a carry bit. So I haven't yet accounted for this carry bit, so I'll have to add that out here. We'll have carry and set it to 0. All right, now using this as our guide, we can get started. All right, so if All right, if our a value is 0 and our b value is 0, then we can say our result plus equals 0. But what about our carry bit? Because we could always have a carry bit as well. So now we have to say if a is 0 and b is 0 and our carry bit is 0, then our result will be 0. Okay, now we have to do this for every single combination of a, b, and carry. Let's take care of that. Now, one thing to note here is I will make these else ifs because we don't want to run more than one of these every time we go through the loop. Okay, so let's just start with these three. We have 0, 0, 0 will result in 0. Now, let's say if we have a 1 and a 0 and 0 carry, well, that's going to result in a 1. And if we have a 0 and a 1, that'll result in a 1 as well. And now our last one for this grouping, we have a 1 and a 1. That's going to result in a 0, but we will have a carry bit, so we have to set our carry to 1. So this takes care of our a and b variations with a carry of 0. Now we have to do the same thing for a carry of 1. And I will make this an else if. Because again, we only want to run one of these every time through our loop. Okay, so now in this case, if our carry is 1, all right, so if we have a, b, 0, but carry of 1, our result will be 1, and our carry gets reset to 0. If we have a is 1, b is 0, but we have a carry, then those are two 1s, which gives us a 0, and our carry remains a 1. All right, same thing here. If we have a is 0, but b is 1, we have two 1s, which gives us a 0 for our result, but our carry remains a 1. What about three 1s? That's going to give us a 1 in our position, and the carry will stay a 1. I don't need to set it. Okay, so that takes care of our loop. Now there are two more things we still need to take care of. So one thing is easy to overlook, and that's if our carry bit, if we run out of characters for both string A and string B, we might have one additional character for our result if there's a carry bit. So if we have a carry bit, we need to add a 1 to our result. Now the other thing that I didn't point out yet, we are going from right to left, calculating this sum. Our result, however, is being appended to, meaning it's growing from left to right. So our result is actually backwards. It's flipped from what we want. Well, that's okay. We can fix that. We can say result is equal to result, and we will slice it taking a step of -1, which will actually flip our result. And that should do it. Hopefully, once I get rid of this stuff that doesn't actually work. All right, I think that should take care of it. Let's give this a shot. All right, we passed. Let's submit that and see how well we do. All right, and we pass. And not too bad either. We beat 95.8% of other algorithms for runtime, and we beat 18% for memory. Hey, that is not bad for a first attempt. And looking at the algorithm that we came up with, it's got a lot of code in here, but because we use these else ifs, we're really only going through one branch every single time. I guess that saves us in processing. All right. So that's not bad at all. I will say there are definitely ways you can make this code more compact. It doesn't necessarily make it any faster. All right, hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can go out and try this one on your own. There's lots of different ways to actually do this problem, so check them out. And please write better code.